After World War II, the United States and the Soviet Union scrambled to capture German scientific and technological expertise. Through Operation Paperclip, the U.S. recruited over 1,600 German scientists, engineers, and technicians, many of whom had been members of the Nazi Party. These individuals brought with them cutting-edge knowledge in rocketry, aeronautics, medicine, and electronics. The most famous among them was Wernher von Braun, who later became the architect of the Saturn V rocket that took humans to the moon. But beyond von Braun, hundreds of other German minds contributed to American dominance in fields like jet propulsion, guided missiles, and nuclear technology. This brain drain effectively transferred the entire German military-industrial complex to American soil, accelerating U.S. technological superiority for decades. The V-2 ballistic missile, developed by Nazi Germany, was the world's first long-range guided ballistic missile. After the war, the U.S. confiscated over 100 complete V-2 rockets and components, along with thousands of blueprints and technical documents. These were shipped to White Sands Proving Ground in New Mexico, where American engineers reverse-engineered the design. The V-2 became the basis for the Redstone rocket, America's first ballistic missile and the launch vehicle for the first U.S. satellite, Explorer 1. The technology also directly influenced the Jupiter C and Saturn rockets. Without the V-2, the U.S. space program would have been set back years. The Germans had solved critical challenges in guidance systems, liquid fuel propulsion, and high-altitude flight, providing a head start in the space race. The Messerschmitt Me-262 was the world's first operational jet fighter. Captured examples were brought to the U.S. and thoroughly studied. American engineers dismantled and analyzed the Junkers Jumo 004 turbojet engines, which had a novel axial flow design. This technology was incorporated into early American jet engines like the General Electric I-16 and I-40. The Me-262's swept-wing design, which reduced drag at high speeds, was also copied for the North American F-86 Sabre, the U.S.'s first swept-wing fighter. The Germans had already solved many problems of supersonic flight, including compressor stalls and material failures. The 10,000 hours of German jet engine testing data saved the U.S. years of research and millions of dollars. Germany developed some of the first practical infrared devices during World War II, including night vision scopes for tanks and anti-aircraft systems. The U.S. captured prototypes and documents from the Zeiss and AEG factories. American scientists perfected the technology, leading to the development of the N/PVS series of night vision goggles used by troops today. German work on infrared homing, for short-range missiles, also laid the groundwork for the Sidewinder missile. The first generation of U.S. heat-seeking missiles borrowed heavily from German design concepts. Additionally, German experiments with lead sulfide detectors and cryogenically cooled sensors directly contributed to modern thermal imaging systems used in medicine, surveillance, and space exploration. Germany had multiple guided missile projects underway, including the Wasserfall surface-to-air missile and the X-4 air-to-air missile. After the war, the U.S. recovered thousands of documents and partially completed missiles. The Wasserfall's radio command guidance system was reverse-engineered and improved upon for the Nike family of surface-to-air missiles, which protected U.S. skies during the Cold War. The X-4's wire guidance system, although crude, influenced early American anti-tank missiles like the SS.10. German research into rocket propellants, aerodynamics, and control systems also accelerated the development of the U.S. Navy's Regulus missile and the Air Force's SNARC program. Without these captured technologies, America's missile defense capabilities would have been far less advanced during the 1950s.